All right, continuing with Unit 1, moving on to talking about angles. So building upon our knowledge of lines, segments, rays, an angle is formed by two rays. If you remember, a ray is one endpoint and one side that continues on forever, arrow in one direction, with a common endpoint called the vertex. So the vertex is this common endpoint B where the two sides meet. There's three ways to name an angle, just like there's multiple ways to name a line, multiple ways to name a plane, three ways to name an angle. The first is by the point that is the vertex. So we would say angle, our symbol that looks like an angle, angle B. We could also use a point on each ray and the vertex. This is going to be helpful when we have multiple angles in one figure. So we would say angle ABC, ABC. Just notice, please, that B is always in the middle because that's your vertex, or CBA. This is why I was discussing with you in class that when we use three letters, we're naming an angle, not a line. And then if there is a number inside, we could use that number, angle 1. Sometimes there'll be a number located inside, sometimes there won't. The set of all the points between the sides of an angle is called the interior. So this would be the interior of an angle, while all the points that are located outside, this would be your exterior. Set of all the points outside the angle. All right, let's try an example together. Here we have multiple angles, all with that vertex A. We have this smaller angle, we have another smaller angle, and then we have this large angle that makes up both of them. So that might help you answer number 1, where we would like to name 3 different angles. You would need to use this method, the point on each ray and the vertex, because multiple angles are using vertex A. So we could say angle BAC, that would be the green one. The purple angle would be angle CAD, and then the larger blue angle would be angle BAD. Okay, name a point in the interior of angle DAB. DAB is right here. The only point in the interior would be C. And then name a point in the exterior of angle CAB. This is CAB. The only point in the exterior would be D. Okay, when we're classifying angles, when you see the word classify an angle based on their measure, then we're asking you to classify it based on this angle measure in degrees. So angles are measured in degrees. 360 degrees is a full circle. 1 degree is 360th of a circle. So if we look at this first angle, we see that, and you're probably familiar with these terms before, we see an angle that's less than 90. That would be an acute angle. An angle that equals 90 degrees. Right angle. An angle that's greater than 90, obtuse. An angle that forms a straight line, or 180 degrees would be a straight angle. So let's put that definition on each of these. An acute angle is an angle, I'm just going to abbreviate with our symbol, an angle measure greater than 0 and less than 90. A right angle is when the angle measure is 90 degrees. If I'm going too fast, just remind you guys, you can always pause the video and give yourself time to catch up. An obtuse angle, an angle measure greater than 90 degrees. And less than 180. And then finally, when you have an angle that forms a straight line, the angle measure is half a circle, which is 180 degrees, and it's formed by two opposite rays. Remember, our definition of an angle is an angle formed by two rays. If the two rays form a straight line, we call those opposite rays. That's something we learned in section 1.2 or 1.1, the previous lesson. Okay, let's go measure some angles using a protractor, and then we'll classify them. This is an example of a protractor. I have a couple in class that we might use later on this year. A protractor just measures angles in degrees. So if we want to find the measure of angle BOA, just follow along from B. O is going to be the vertex on all of these angles, A. And just be careful, you have a set of 2 points here. You have a set of measures on the outside that are increasing, and then on the inside that are increasing, going from right to left. Well, if we have one of our rays on this right side, we want to use these inside numbers, starting at 0 and going all the way up to 40 degrees. So the measure of angle BOA would be 40 degrees. Let's keep going. Let's try a few others. Angle DOB. Erase my work here. Okay, this one might be a little more difficult because neither ray is on the flat part of that protractor. So we might have to do a little bit more math here. We know that, and if you want, you guys could just count. You can count by 5s or count by 10s. It looks like this is at 15. And it looks like, and again, we're using the outside numbers now because we're going from right to left. You could also use the inside if you we're going from left to right. If you wanted to use the inside, you'd be going from right to left. We're using the outside numbers, so that means here we are at 140. So I think it's really helpful to use this 90 as just a halfway point. So 15 is 75 degrees away from 90, and 140 is 50 degrees away from 90. Just add those two measures together. 70 plus 50 is 125 degrees. You could count one by one if you want. I think that's the easiest method for you guys, is to use 90 as your halfway point. Why don't you guys try the last two on your own? That would be angle EOC, and angle AOE. Try these both on your own, and then we'll see what you guys got. For C, you should have gotten 105 degrees, and for AOE, straight line, straight angle, 180 degrees. Okay, you were just using a postulate. Remember, a postulate is a statement that we assume to be true. The protractor postulate, like the ruler postulate, simply states that you can line up each ray to a given number from 0 to 180 degrees. We're going to add a little bit more into here using this image. So if we're given AB and point O on AB, all rays from O correspond to a real number from 0 to 180 degrees. Okay, and you guys saw that earlier. If we have ray OC right here, OC corresponds to a real number right in between 40 and 50, or 130 and 140. So whichever side you're looking at, 45 or 135. Okay, protractor postulate. Another postulate, just like the previous section, we had segment addition postulate. We also have angle addition postulate, which we're going to practice in a sec. Angle addition postulate states if T, we're looking at T right here in this diagram, is in the interior of angle QRS, then if I ever use this lowercase m, it just stands for measure, lowercase m, then the measure of angle QRT plus the measure of angle TRS equals the measure of that whole angle QRS. So simply stated, this angle plus the red angle equals the whole entire angle QRS, and that's what you guys have right here. Okay, let's go practice using some angle addition postulate on these two examples. Let's do A together and we'll let you guys try B on your own. For A, you're told DEG. DEG. Remember, M again stands for the measure of angle DEG. 115 degrees. Then we are told DEF. DEF is 48 degrees. DEF is right here, 48. I would like to know what the measure of angle EFG is. That would be this angle right here. Well, if you know what the whole angle is, and the smaller angle that's one component of that angle, we could just say 115 minus 48 gets us a measure of 67 degrees. For the measure of angle FEG, you can check your work by doing 67 plus 48. Make sure you get 115. All right, why don't you guys go ahead and try and work out B, finding the measure of angle YWZ. YWZ. You should have gotten 62 degrees. Okay. If you need help on that, we can go over that in class this week. Let's finish with talking about congruent angles. Just like we had congruent segments, congruent angles are angles that have the same measure. Okay. So if you're told that the measure of angle ABC and DEF are congruent, you'd see a couple things. You'd see the same number of arc marks on both angles. You also might see this statement: angle CBA is congruent to angle FED. Again, this congruent symbol in between means the angle measures are the same. You always have congruent angles when you have an angle bisector. Okay? Bisect means split into two, or divide an angle into two congruent parts. So if you're told JK is a bisector of angle LJM, then these two angles would be congruent and you would see the same number of arc marks on each. Okay? So let's practice a couple congruent angles on here. You are told that KM bisects angle JKL. So let's put those congruent markings on these two angles. Then you're also told the measure of angle JKM is 4x plus 6. And the measure of MKL is 7x minus 12. We want to find the measure of JKM, which is this angle. The measure does not mean, oh, it's 4x plus 6. No, I want to know what that exact measure is, which means we need to solve for x first. And if these two angles are congruent, just set them equal. Congruent means the measures are equal. So set 4x plus 6 equal to 7x minus 12. Start isolating your variable. Move the 3x to the other side. I'm sorry. We have our x's on the same side. Move the 12 to the other side. 18 equals 3x. We get x equals 6. Don't forget to plug the 6 back in. 4 times 6 plus 6 gets us 30 degrees. Okay. I'm going to let you try C. Actually, why don't you guys try B on your own? I'll help you by drawing this out. Angle PQR. PQR is bisected by QS, so QS should go right down the middle. S is somewhere on this ray. Show these are congruent. PQS is 5y minus 1, and PQR is 8y plus 12. You know what? Let's actually work this one out together because it's a little different. The 8y minus 12 is for the whole angle, so if we know this angle is 5y minus 1 and they're congruent, then we can assume this side is going to have the same measure, so let's use the same expression. And now we can use angle addition postulate. 5y minus 1 plus 5y minus 1 equals 8y plus 12. Combine your like terms. Isolate your variable. And we get y equals 7. We want to know the measure of PQS, which is this angle right here. So let's plug that 7 right in here for y. 5 times 7 minus 1 gets us 34 degrees. Okay, last but not least, for C, angle WYZ is 2x minus 5, and XYW is 3x plus 10. Hopefully you remember our definition of a straight angle. It's an angle whose measure equals 180 degrees. So if these two angles make up a straight angle, we could say 3x plus 10 plus 2x minus 5 equals 180 degrees. Combine like terms. Isolate your variable. And we are not plugging anything back in here because it just says find the value of x, so we're done when we get x by itself using inverse operations. 35. If the problem asks for the measure of angle XWY, just plug it back in. Okay? If we're just asking for the value of x, that's all the work we need to show. Okay, a lot of math here, similar to section 1.2. If you have questions, please reach out, use the Google chat, ask each other. We'll go over these problems again in class.